Hello class, and this is a very short demonstration video on how to verify your design for your filters. And for this one, we'll be demonstrating the effect of this filter in our range of frequencies that we will be dealing with if ever we'll be using this filter. So this is obviously an example of a very simple high pass filter, right? And so for this one, let us first investigate the value of the cutoff frequency for this particular high pass filter combination of C1 and R1. So for that one, we just have to solve for uh, their cutoff frequency. So the formula is 1 over 2 pi RC. So we have 1000 ohms and capacitance of 1 times 10 to the power of negative 6, right? So that's 1 microfarad. So we would expect to have a cutoff frequency of 159.15 hertz. So we would expect that around 159.15 hertz, the output amplitude of our circuit is less than negative 3 decibels, or around 3 negative decibels from the original waveform. So for example, if we are dealing with, let's say, 1 volt of uh, of magnitude, or let's say for example if we are dealing with 0 dB of magnitude for the normal frequencies that would be allowed in this particular circuit, then we would expect a drop up to negative 3 decibels at 159 hertz. So let's go ahead and use our Bode plotter. We will be using our Bode plotter for this one to be able to demonstrate the effect of this particular filter. So Bode plotter can be found right here. Bode plotter. So the Bode plotter will allow our circuit to simulate the circuit with different frequencies from 0 hertz up to whatever parameter that we will set in here, and it will simulate the circuit from those frequencies, and it will plot the effect, plot the magnitude at the output of this particular filter. So let's say for example we are connecting this one. So we have 4 connections for this one. All negative should be grounded the same way that we are grounding our circuit, and then input should be connected to the input terminal of our circuit. So in this case, it will be connected to the input of our C1, and the output should be connected to the R, right? So because we are measuring our output as the voltage drop of our R1. So again, the Bode plotter will simulate our circuit in a way that it will try the circuit for 0 hertz, and then it will graph the effect or graph the output amplitude for that particular frequency, and it will increase slowly and slowly and slowly, and it will plot a graph showing all of those frequencies from the ranges that we set in here. So we can actually set the frequencies if we double click this icon. So we can set the frequencies that it will sweep or it will try. So we should see here that we have some horizontal and vertical scale. So the vertical scale will indicate the magnitude, and since we are talking about decibels right here, so we should use the logarithm. Okay, so let's use the logarithm for this one, so that, or the logarithmic scales in the graphing, so that we could easily see everything right here. But anyway, let's proceed with this one. So for this one, it will sweep from 0 millihertz, 1 millihertz up to 1 gigahertz. So again, it will plot the frequencies and the output from 1 millihertz to 1 gigahertz. Of course, you can change this one depending on the parameters that you are looking into. So again, we are trying to verify if it is really 159, the cutoff frequency is really 159.15 hertz. So to do that, to see the graph, of course, we need to uh, click run or F5. So it will plot everything. You can see here that there is a steep slope from 1 megahertz up to some point where it goes to the maximum value. So in this case, class, the maximum value is 0 decibels. So everything below that 0 decibels are negative values. So it starts with 1 megahertz at negative 104.36 decibels. So if we move this cursor right here, we could see the changes in the frequency and the value of the logarithmic scale right here, or the decibel value of the power of the output signal of that particular circuit. So in this case, let's go ahead and see if we can point it to negative 3 decibels. Okay, moving. Okay, so we are now at this point, this is already negative 3.004 decibels at 159.387. Now, from our calculations, we have 159.15. So probably there are slight changes because this is negative 3.004 decibels. But in this case, we could clearly see that since this is a high pass filter, so there is imminent attenuation on the lower frequency end, and then it will maximize on the upper frequency end. And obviously, because this is the negative 3 dB point, which is the point wherein we could verify the value of our cutoff frequency, and we will clearly see that at negative 3 decibels, we have 159.38 or 39 hertz, and that would confirm our calculations. Now you could do the same for your different frequencies and different circuits. So you just have to use the Bode plotter.